Hello everybody to the PTV Viswalk webinar on BIM and elevators, lifts, converting BIM files, IFC files to Viswalk. Model file has been a new feature in the 2015 release, PTV Viswalk 8. And the elevators are the main new feature in PTV Viswalk 9, and the two can be combined in a very interesting way, and nice models can be made quickly. So first, maybe for everyone who's not yet familiar with BIM, what is BIM? What does it mean? BIM is an acronym for Building Information Models, and as you see here, as today probably the most relevant definition that is given in the public realm at Wikipedia. So it says that it's a process involving the generation and management of digital representations of physical and functional characteristics of places. That's of course a very general formulation, and yeah, a digital representation of places, of buildings. Okay, what is it? A database? Is there a specific file format? And yes, there is a specific file format, at least one, more than one. The IFC format. IFC is also an acronym which stands for Industry Foundation Class, and it's an open standard created by the Building Smart collaboration, and we have realized that this IFC format fits pretty well to our Viswalk file format, and that therefore it's a particularly good idea to build a converter from IFC to INPX, our Viswalk and Visim format. BIM, you could still call it that it is a pretty new idea, but nevertheless all of the main large softwares which are available for architecture planning, building planning, they have exporters to this IFC format, and you can usually find the details in on the help web pages of these manufacturers. So for AutoCAD there is one for Archicad, there is one for Vectorworks, just to mention a few. Sorry for everyone whom I forgot. It's just to tell them. I didn't find any software which is still lacking such an export function. So when you're using one of these, you can export IFC files, and these then can be imported to Viswalk, first converted and then imported. Another interesting thing is, as a quick start to try the functionality, you can find, meanwhile it's quite a large number of example files, models of very, very different sizes, so from nearly trivial minimum size examples to very large and complex projects, and these can be found on the web, particularly here in this open IFC model repository, which is hosted by, I think, the University of Auckland, New Zealand. And from these I have picked one particular with an intermediate size. It's a conference center, and it has something like 7 or 8 floors. It's a non-trivial structure, but also not so complex that you cannot manage it within one webinar. So it fits our purpose for today. Now, there is a free software to view such IFC files and the buildings which are modeled in these, and it's the XBIM Explorer. You can download it, install it on your computer, and then have a look into these files, how they look, how the BIM modeler, the original modeler of this building, has imagined this file to look like. Here is the example model which I have picked, and I want to convert that now to a Viswalk file. I'll just start the converter, and then we can have another look at this building in the XBIM Explorer. So what you have to do is File, Import, and then BIM IFC. Which calls this dialog. Then, of course, first you have to select the BIM file. It's here, and you see it has something close to 70 megabyte. And then the next thing is that you choose where to save the result file. It should have a file name extension of INPX. And then there's a couple of settings where often it's fine to leave everything as it is. I think the most important settings are the first two. So since BIM is, or IFC is really 3D, and all objects can have arbitrary shape in all dimensions. But Viswalk, on the other hand, the 3D is a layered 2D. We have to choose at which height we intersect through the BIM model, where then the projection of this intersection to the ground of the obstacles defines where in Viswalk there is an obstacle. And that is by default here it's 1 meter. Then the next thing is that in IFC you can have really arced or circle-shaped or ellipse-shaped objects which are really round, so which are defined, if it's a circle, just by the central point and then a radius. And that's a perfect circle which is defined by that. In Viswalk, such a perfect circle object does not exist. What you have is polygons, so each circle is an approximation. And this tolerance here means the larger this number is, the fewer vertices will the polygon have later on, which approximates the circle. Then you can choose if they are available, automatically display types should be created from materials. Will make your file potentially a bit larger, your Viswalk file. You can choose if slabs which have an incline should be split into terraces. So if this option is not checked, then the file will, the slab, the area will be projected to be a flat area. But if this option is checked, then a couple of areas might be created, and you have a terraced set of areas which also approximates the incline of the original slab in IFC. Of course, objects in IFC can have some attributes which do not exist in Viswalk and which you do not need in Viswalk. But nevertheless, you might want to see them in Viswalk just for information for yourself. And there you can say with this option here, that these non-Viswalk relevant attributes should be imported and automatically user-defined attributes should be created. And the rest is just telling the converter which type of objects should be converted and imported to Viswalk. Of course, slabs should be made to areas, and also a set of objects in IFC can be imported as obstacles in Viswalk. Also stairs can be imported and ramps. You might be surprised that here you do not see escalators in the list. The last time we checked, that was half a year ago, escalators did not have a specific, or they were not a specific object in IFC. They did not exist. So it's just a matter of the definition of the open BIM IFC standard. What does not exist there is we cannot import it. It probably is modeled as a stair then. And the same holds for the elevators. Elevators are more or less modeled currently in IFC as obstacles cutting through all of the levels, or just as holes. So there is no object which holds the full information which is associated with an escalator, like capacity or whatever. So also, as it does not exist, we cannot import it. So now I just start the conversion process, and it will take about 70 seconds. So in this case, about 1 second per megabyte. That's just a rough orientation. I have seen a file with 180 megabytes, which took much longer than 3 minutes, namely 30 minutes to be converted. And there are other files where conversion goes within 2 seconds. But roughly, the larger the original file, the longer the conversion takes. And yeah, so we can have a look at the IFC file. You see this building, it has 2 parts. One part is pretty much rather a simple traditional style of a building, and then the other part is with a lot of glass, and also the level structure is more complex. So you see here stairs connecting levels in kind of a creative way. So that's more the open area of this conference building. And here is more the traditional conservative part. And if I take away the walls, we can also see the interior structure. So there is a stair hall there, which goes from the ground floor and even underground to the top, and in this way connects all of the levels. And here it is from the other side. Meanwhile, the conversion has been finished. You get a pretty extensive log. It's also saved into a log file where you can check if you miss an object, if it was a matter of the intersection height, then there is no line written in the log, or if there was a problem with the data. And so I close this and I quit this, and you might be surprised that in the Viswalk there is not yet anything added, so the model is still empty. We can see it here, there is no area, nothing. That's because it's a converter. So what the converter does is to create a Viswalk file with only the geometry. That has 2 reasons. As I said, it can happen that when you have a large project file, the conversion might take 1 hour, then you can still continue to work with your Viswalk and Vissim license. It's not blocked, like if it were, if the model were directly imported into the network editor. And the other thing is, since the resulting Viswalk file only contains the geometry and nothing else, so it's reduced, does not contain all of the defaults, it's much simpler for us to maintain it from version to version. So the defaults might change, defaults might be added, but with this stripped down file, which only contains the geometry, it's almost 100% compatible from main release to main release of Viswalk. But therefore we have to now read additionally this resulting network, and you can see here that's it. So it was created just a few minutes ago, and you see the Viswalk file is much smaller than the IFC file. So obviously not all of the data which is included in this IFC file is required for Viswalk. And I open it, and also you see in this data file many object types do not exist which are available in Viswalk in principle. What does exist are of course user-defined attributes, the network settings, display types, levels, areas, ramps, stairs, and obstacles. Of course, that's our main purpose, why we do this. So here we are. That's how it looks in 2D. Everything is selected, because before we have a view at it in 3D, let's just look at the list of areas, and you see it's already a pretty impressive list of areas which could be imported in this way. But for the obstacles, it's even more impressive, since there we have more than 1,000 obstacles which could be imported and which we did not have to create manually. Now have a look at it in 3D. For this I just open a second network editor window, and we look at it side by side. And here we are. So that's our building. It does not exactly look as elegant as it looks in the BIM Explorer, since the transparency is not shown, the glass windows are not shown, but it fits perfectly to the purpose of Viswalk, so it includes the information which we need. You also see that the obstacles, they are imported with the height they originally have. That's it's a feature, but it's more comfortable for us here, and it fits our purpose better if all obstacles are just shown with 1/3 of their actual height, because then we can have a look inside the building, which is similar to looking through the windows or hiding the walls in the BIM Explorer. So then it looks like this. Also, the level structure is imported or is converted from IFC to Viswalk, so we did not have to create these levels beforehand, but they are extracted automatically from the IFC file and automatically created in Viswalk. I can tell you that these levels which you see here, more with the higher IDs, they are mainly for use here on this side, and it's easier for us when we then go to adding the lift if we show only those main levels which have the rather lower IDs. It's these. You may already have realized that the 5th floor exists here 2 times, and that's just because the architects have included 2 variants of the 5th floor, one when there's an exhibition and one when there is none. And for us, let's stick just with the version without this additional information which has been put between 2 levels. So that's not realistic that here there is actually another level, but it's just a variant of the 5th level, so we just hide it. Also interesting is that there is different colors. Now let me see if I find an orange level, an orange object. So there's different colors. Gray means walking area. Green means it's a wall, an obstacle. Orange is also an obstacle, but it's an obstacle which in IFC was a hole in the ground. In Viswalk there are no areas which have a hole. In IFC these exist, so this is modeled in Viswalk with the combination of an area and an obstacle, and then such obstacles which in fact are holes are shown in orange. And the last color which is used in the imported or in the converted file is red, and red means that the converter realized there is an issue here, and this issue can be either that in the IFC file something does not match exactly the IFC standard format. So these exporters from the CAD software, they do not always stick with the exact file format of IFC, and that can trigger problems when you import it to Viswalk. And the other reason obviously can be that the object which is to be imported has an internal structure which cannot be represented in Viswalk. And I don't know what is the case here. It could be that different to the ground floor where the stairs are modeled individually, as you can see. Then above, these 3 stairs and 2 platforms are modeled as one piece, and this does not yet exist as an option in Viswalk. And then it's red, and the importer in this way tells you as a modeler you need to work here. But with other stairs, as you can see here, the import works quite well. So maybe we find it once more in the original file. So that's this same view here, about the same view. So these stairs could be imported from IFC, but not in this other stair hall. Maybe save this view. No, it's not the front, it's the back of the building. and so we can come back easier to this later. Okay, so much on the BIM import. I'd like now really to use this for a small pedestrian simulation where pedestrians are generated on each of these main levels, and then each pedestrian has a destination on some other level, and in between they are meant to ride an elevator. And for this I just begin creating the demand. So now in 2D I create the first area. And since I want to use it for demand generation, I check always uses origin area and always uses destination area. Maybe we can give it just a different color to mark these areas which I have created additionally to the areas which were imported from the IFC file. So additional areas and here I need to check use display types. So here we are. Now since this ought to be used on, or the building has 7 floors, I need this 7 times, and now I can in the list of areas send these to all of these other floors. 3rd, 4th, 5th, and the last one. Good. Next step is to put each of these areas on its floor to some reasonable position. It can be inside of one of these rooms. And the last one. Then obviously what I need to do is these red obstacles here, which mark that there was some problem. I need to delete them to create some space for the lift. And before I build the lifts now, just to test, to check if it works and what is still missing, it's for the first time I can click run simulation without expecting that already it would work, since so far not much has been done. Show, okay, there is some information that there is a problem with some obstacles, that these cut with, they intersect with ramps. Okay, and that's the same for all of these messages. So what's going on here? We see at least this obstacle number 734. It is a hole obstacle. Okay, there is a ramp which is going through a hole. That makes sense. So our hole marker obstacle, I just deleted. It is anyway relevant only in this other part of the building, which from now on is not relevant for us since I built the lift into the other part, the narrow part. Obstacle number 752 is also making some trouble, and it's the same. It's a hole obstacle, and also this one I can simply delete. And what's going on here? It seems to be on some level which is not at all relevant for us. And the last one, also display type holes. It's also a hole obstacle, and it's also on a level which from now on is not relevant for us. Good, so we have worked for these issues. Now I forgot one thing, namely after I had created the origin and destination areas, I need to actually produce some demand, and since it's from each level to each other level, it's totally sufficient if we have for each origin destination relation 10 pedestrians. It sums up to quite some numbers in the end. So here we are, and that automatically generates our inputs. Here they are, and routes. So that's the routing system. Good. So maybe now we have a chance. No, we don't have a chance that the simulation runs if I click start. It's just to check if there are some issues. Probably there are. I want them to walk to use the lift. There is no lift, and the staircase which was there in the IFC file also does not exist. So no surprise, it tells us no walkable connection. Therefore, but since the no walkable connection between origin and destination is an error message which we had expected anyway, we can now confidently, or with some confidence, continue and add the lift. So where would it be best to add the lift? We see there is from the first floor some stairs going to the second floor, and only then there is nothing in the way. I don't want to delete these stairs. Maybe it's interesting to also see pedestrians use these stairs. So let's have the lift running only from the second floor to the 7th floor. It doesn't make sense for a building in a way, but to show the functionality, I think it's fine. So I create an elevator object here, and you see it's already added automatically for all of the levels which are shown. That's what you see in 3D. Maybe it's more interesting to have a look at it from the other side. So here it is, you see the door, and you see that it's also been created on the first floor. Why has it also been added on the first floor? Because the first floor is shown in the levels, and so we want to take the first floor out of the range of the lift, and that is done simply by having a look at the list of doors of a lift, and then I uncheck that the lift should stop on the first floor. Now when the lift does not have any door on a particular floor, it assumes that it shouldn't stop there, that it doesn't exist there, and it's erased from that floor, as you see in 3D. Good, but for all of the other floors, it's fine. You can save the view under the name of front. So, does it already work? No, we get some more messages. The first message we get is the elevator 1 has no active door on the main stop level 1. What's that? The main level. The main level is the level where a lift returns to when it is idle. and in the list of elevator groups, we see that the main level is the base level. There is no object on the base level. The base level existed already before we started the read additionally, so it's the original level, and it doesn't make sense at all to have the lift's main level there. So let's have as the main level the second floor, so the lowest floor where it actually has a stop. Now, instead of running the model for a number of times, we can already have a look at it from the top and reduce or take out of the visibility floor by floor. And we see on the 6th floor there is a wall which just hinders pedestrians to reach the lift, so we can and need to delete it. And if we continue, we see it's the same on the 5th floor and on the 4th floor, but then on the 3rd, 2nd and 1st floor it's fine. So back to original view. I have corrected that, so we can be one step more confident that now it will run. Let's see if it does, or if we get another error message. Another error message. The door of elevator 1 at level 2 cannot be used for boarding nor alighting because the next area is too far away. Okay, what's wrong here? Okay, there's just a gap. For some reason, this area on the floor has a gap here. So we close the gap and see what's the next, what the model checker tells us. Okay, it's also an issue with the area. So let's just go through these areas here and maybe correct, because that can be really a matter of centimeters, or we can simply increase the size of the elevator a bit and then guarantee that it overlaps sufficiently. Some more error messages. Okay, elevator 1 on level 4. So let's have a look at level 4. Level 4 is our level where we don't want it to stop at all. So that's the problem. There is no, we need to take this out as well. That was simply a mistake which I did, that I had it stopped there. Okay, now we get really relevant error messages. No waiting area can be reached from door 1. What's that? Every one of you who has been using Viswalk and Vissim to model a station knows that pedestrians who want to board a train, they wait at a public transport waiting area, and it's just the same for elevators. So you send, or the model sends, pedestrians to a waiting area which is associated with an elevator group. In this model we only have one elevator group, and there they wait, or they give a signal to the elevator group, please send an elevator for this or that direction. and then they wait there for the elevator to approach and to board the elevator. So we have created this one for the 7th floor, and of course such an area is required on each level where the elevator has a door. So the 2nd one, the 3rd one, and while I copied this, you might wonder what this message means. Of course, if I copy a waiting area, it could be that it should be associated with a different elevator group. So assume I'm not only copying the waiting area, but I'm copying the waiting area together with the elevator. And I copy it to a different place in the building. So I want to have a separate group. But Viswalk is never sure, should just be there a new elevator for the same group, or should it be an entirely new group? And therefore, when you do such copying actions with elevators or waiting areas for elevators, therefore this dialog asks you if there should be a new elevator group being created or the existing one being used. So to the 5th floor, and finally to the 6th floor. Let's see if everything is correct. We have 4th, 5th, 6th. There it is on the 7th and the 2nd floor. So each floor now has its waiting area, and we just to see it better, we can give it our specific color. Good. So in principle, we have our infrastructure now. Still messages. First, we see as a message that the door can not be used because the area in front of the elevator is too small for the positioning areas. So Viswalk is creating internally some let's say navigation points, positioning areas where the boarding pedestrians wait and give way to alighting pedestrians. And since here we have a very narrow geometry, there is not sufficient space, but we can fix it easily in this case by just reducing the width of the doors to a smaller value, and then also the positioning areas are closer to each other and further away from the walls, and that alone works. And as you see, you can configure the width of the doors of an elevator with this number. Good. And the second error message which was in the window was that still there is no connection between origin and destination. And in this case now it's because the areas here, they do not overlap. For Viswalk, it's very important that really there is an overlap between areas where pedestrians should move from one area to the neighboring area. For a BIM modeler, this need is not really there. So in such a CAD drawing, you can often see that the areas, the edge is identical, so it has identical coordinates, which means there is no overlap, and or there might even be a small gap, and therefore regrettably we have to compensate for that and go through it level by level. And that's really an issue of the purpose of a model. The IFC model is not made for the purpose of simulation in this case. I downloaded it from the internet, and therefore areas don't overlap. So we have to do this manual correction. But I think in the end you will agree that it's really not a lot of manual cleanup work which has to be done before the model in the end really runs and simulates, in fact, and you see the results. So here we have our first pedestrian walking towards the lift, waiting for the lift. The lift is approaching, door is opening, lady walks inside and is going up. Why are these other two not boarding? Because they want to go downstairs, but they realize the lift is first going upstairs, and therefore they keep waiting. Now they board. One guy is leaving the lift. There they leave, and okay, these two walk the long way and go down the stairs here through levels which which I have hidden. Fine. So still it seems that the connection here does not exist. So let's check what is going on there. So I just hide these two levels so we can better see it. And I also hide these three levels which are relevant here. We have our first floor, fine. The first floor has these stairs here going up to the first platform, and then we would assume the first platform is here and one stair continuing. But we also already see the second stair going to the second floor, but the platform is missing and the platform is on a different level. So obviously here either something in the IFC file was not associated with the correct level, or at the conversion something worked not properly. So we can go to the list of ramps and stairs, and just see what data we have here. And we see it's actually indeed going from level 12 to level 12, but we want it to run from level 12 to level 13, but then without a C offset. Okay, that works. Now what's wrong with this one? It's going from level 12, not from 13 to the second floor, and it has a C offset, but if we have it running from level 13 without a C offset to the second floor, then finally our model will do what we expect. So overall it was not a lot of cleanup work, but some was to be done, and as you saw in the end, while some of the required cleanup work was pointed out with error messages, this last cleanup work was not, because there was an alternative path over different stairs, and we had to get aware of it ourselves. That's always the disadvantage which you have when you don't do a model from scratch yourself. You don't know it as exactly as you would if you would do. But still, I think the benefit of importing more than 1,000 obstacles within a few seconds or minutes outweighs this, that at some point of your project you need to do a careful check if it really does what you do, or if there are some surprises hiding somewhere because in the IFC file someone did not work properly with the level configuration or the level definition. Good. Again, for everyone who knows the public transport feature in Vissim and Viswalk, you might ask yourself, is it the same like when pedestrians board a train, that they disappear when they go inside an elevator? We can have a look. We can have a look by going back to the display types, adding a display type, calling it invisible, not forgetting to make it invisible, and then at the elevators I make everything invisible which hinders us from looking inside the elevator. So everything that remains to be shown is now the floor and the door. So in the next simulation run we can see what's going on inside of the lift. So different to public transport, our pedestrians remain existing, they don't die and are reborn, but they continue their life, they continue their route, everything, all of the data, everything that is associated with a pedestrian is maintained. It's just like if they were moving stairs, if they were moving over an area, only that it is vertical. So let's just have a look at the data which is associated with an escalator. There is a number, some geometric data like the cap height. So assume you have an elevator which above the top floor where it's the highest floor where it's which it is serving, there is further floors, then the cap height decides if the next higher floor still has cut out a hole. You can set the capacity. That's of course one of the most interesting properties. I will demonstrate it after going through this dialog. A couple of display types, also some dynamic attributes like the current level, the destination level, estimated time of arrival, something which you can use when you use the COM interface, the motion state, going if it is waiting, door opening, going, and the travel direction. The group to which an elevator belongs, of course, and yeah, I think that's it more or less. So let's have a look at the capacity. To really see the effect, I just set it to 1 to limit it to the minimum value. So the capacity of an elevator is determined first by its size, by its area content. So when you put at capacity a high number, which is unrealistically high, then pedestrians will always try to get inside, but after some time the doors will close, but only if there's no one standing inside the door blocking it. So a large crowd of people waiting in front of an elevator, making persons being stuck inside the doors can block an elevator from traveling. But when you set this number capacity to a small value, which is so small that this number of people easily have space, then the capacity number defines at which point pedestrians really voluntarily stop from boarding and go back to their waiting position. So let's just set it maybe to a value which is realistic for the area extent which we have, let's say 6. Then also the elevator group has a number of properties which are the physical performance parameters like acceleration and the maximum speed, for example, but also the main landing level. Door hold time, door motion time. So really, you can configure it totally in detail to match it with the technical data which you have at the elevator in your particular project. But now that I have been Speaking of elevator groups, already throughout the webinar, let's have really an example where there is two elevators which are operated in a coordinated manner and where pedestrians then have just an increased capacity because there's two elevators. For that to make sense, I just double the demand and for simplicity I just pick this elevator, copy it to the opposite side, and make it larger because here we have space. That was wrong. I picked stairs. I wondered why I cannot change the geometry. So that's the elevator. So this one is larger, and since it's larger I can give it a higher capacity. And now the doors are on the wrong side. You may have wondered already what this edge index means. Yeah, it's the index of the edge where the door is. So if I change it from 1 to 3, the door is going to the opposite side, and we can give this one a much wider door because the elevator is larger. And that's it. So simulation can start, and we will see now this larger elevator being integrated in the entire process, the simulation. Let's keep it selected, then the yellow frame tells you where it is, although it's invisible. So the pedestrians wait on the waiting area, and then for them it doesn't matter, they just go to that elevator which is closest to them and is the first one which serves their need, which serves their direction. Something which I'm not going to demonstrate, I just tell you, is that an elevator in principle, first the door can be on different edges, on different levels, and there can also be more than one door on a level. In principle, an elevator on each floor can have a door on each edge. So 4 doors on a level, and pedestrians would use all of them to alight or to board. Good. So that's it from what I wanted to show, to demonstrate you. We still have some time, I think, so you can ask questions using the questions functionality here. I already see one question, how about elevator speed? I think I have already answered this one. I hope to your full content. Okay, I see a yes. So yeah, please, if there are any more questions, ask them. Weight capacity is done by COM. Yes. So if you want to model the capacity not with the number of pedestrians but with weight, so if you have a population with a wide variation of body sizes and body weight, you would have to use COM, I think. Yes. So that is currently at the GUI, there is no possibility to model an elevator which really measures the total weight of people who are inside. Yeah, so it would be one extension, one possible extension of the existing functionality which we have. There is very many extensions which we could think of already in the time when we developed it, but at some point we had to do a cut and say, let's go release it as it is and see from the feedback what the users need most. So we are very, very interested in hearing your feedback from your projects. What works well, what helped you most, but also what you think is most needed as the next step of extending this feature. Yeah, I see a question which is going to the control algorithm. What about no demand case? Will the elevator skip that floor, or will it stop on every floor? The control algorithm is yeah, the elevator algorithm it is called. I think it SCAN, S-C-A-N algorithm. So it serves all calls, all demand into the current movement direction until there is no more demand in that direction, and then it turns around. And if there is nothing to do on a particular floor, it does not stop, so it continues moving. An elevator which stops on each floor would be the so-called Sabbath algorithm, because it's forbidden to operate a machine on Sabbath for Jews, and there the elevators are in Sabbath mode on Sabbath. The control algorithm currently is fixed, so you cannot choose it, you cannot change it, not even by COM. To my knowledge, in large buildings, predominantly, mostly everywhere, it's either the SCAN, so the standard elevator algorithm which is used, or a very much customized algorithm which is developed for that particular building. So for us it made sense to only offer the SCAN algorithm, but also there, if you have a need, a demand for some other control algorithms, tell us and be specific with it, what you need, and we can develop something. Do all doors open at the level where the elevator stops? Yes. So if you want to have a closed door, then you just model no door. We think about offering the possibility, as we have with public transport, that you can say this is a door only for boarding, or this is a door only for alighting, so that you model through lifts. We already have heard this request from users, so that might has a chance to be the next extension step. Can pedestrians go in and out the lift at the same time if the door width is wide enough? No, the boarding pedestrians wait until alighting is completed. So we assume if the door is really wide, then let's say if it's 1.20 meters and it's only one person, that then it's so fast that this one person leaves. You don't realize that you could board from next to this one person. And if it's two persons alighting, that they alight side by side, not one after the other, leaving already space for the boarding pedestrians. How does it impact with the capacity? I don't understand this question exactly. The baby pram, I don't know. Can elevators skip levels if the capacity of the elevators have reached? No, they don't skip levels. in this case, because we assume that the elevator is not aware of the capacity being reached. So we assume there is no weight measurement, so the elevator is not informed about capacity issues. And we also assume the elevator does not know that at a particular level no one wants to okay, no, we could assume, so the information is there, we could assume that the elevator could know, but in that control algorithm we ignore that the information is in principle available. In Viswalk currently we don't have really a simulation of prams. So if you have a 3D model of a pram or someone pushing a pram or a pushchair, then this model is larger and it takes more space inside the elevator, and that means that fewer pedestrians fit inside. So in fact there is an impact, but the entire dynamics of pushing a pram would require a very fundamental extension of really the basics of the simulation model, of the dynamics model. If it's okay that it looks like sliding a bit on ice, then you can include it in your model. And when someone with a parent with a baby pram go inside an elevator, they will take more space and fewer further people will fit inside. Okay, I think I have caught up all of the questions which you typed in. Or if you don't have any further questions, I say thank you for dropping by and visiting the webinar, and see you sometime later, maybe see you in real life at one of our events, and enjoy simulating. Thanks. Bye.